Hello. As you can see, welcome back. People who have watched the last 2-3 lessons will know we have discussed all these things. I'm just putting them up so that I can take some questions. So we know the definitions: cosec is 1 over sine, sec is 1 over cos, cot is 1 over tan. We also know tan is sine over cos, cot is cos over sine. And we discuss how we get all positive, sine positive, tan positive, cos positive in the quadrants. And in the 3 lessons ago, we derived the 3 fundamental identities which are true for any angle theta. And in the last lesson, I discussed how to find ratios of more than 90. How do we apply this? For example, I wanted sine of 312 degrees. And I don't want to use a calculator. I just want it as an acute angle. In terms of an acute angle, 312 I can write as 360 minus how much? 48. Okay, sine of 360 minus 48. But I don't want to use a minus. I don't like minus. Okay, I'll say it is sine of 270 plus 42. Either way is fine. So first job will be bring an acute angle. Take the nearest to 90, either add an acute angle or subtract an acute angle. And it has to be a multiple of 90 plus something or multiple of 90 minus something. Okay? Done. Having done that, but that something must be an acute angle. Good? 360 is 90 times 4. Sine of 90 times even, sine remains as sine, but before we go there, 312 degrees, 0, 90, 180, 270, 360, 312 is in the 4th quadrant, where cos is positive. Your fundamental angle you're finding is, the ratio is sine, so it's going to be negative. Once you do that, you've already done the quadrant. So you're not bothered. Next, if it is an even multiple of 90, sine will remain sine. So it is minus sine 48. Or 270 is 270 plus 270 plus. So it's in this quadrant. Again, it's negative. So first thing you decide is which quadrant. So is it going to be negative or positive? Next, 270 is 90 times 3. Odd number. If it is an odd number, sine will go to cos because opposite becomes adjacent. By similar, when you rotate to 90 degrees, and adjacent becomes opposite. So therefore, it's a cos 42. You might be wondering, sir, what are you wrong? What's wrong with you? Says, but if you look at use a calculator, or I want you to figure out, look, if you have a right angle triangle, if this angle is 48, that angle is 42, let's assume the hypotenuse is 1. So do you agree the opposite is sine, the adjacent is cos? Yeah? What is, okay, AB and BC. What is sine 48? AB over 1. What is cos 42? AB over 1. So both are same. Or if you open a calculator and work out, sine 48 will be the same as cos 42. So in other words, if two angles add up to 90, the sine of one of them will be the cos of the other. The cos of one of them will be the sine of the other. Okay? I took a physical example, but questions like this, you have calculator. Why should I bother using all this formula? Okay, somewhere you're doing, says simplify, given that alpha is acute, what is tan of 1080 minus alpha? Haha, your calculator is not going to help you, right? So the first thing you do is Where is 1080? 0, 360, 720, 1080. That is 1080. And then minus alpha. Afterwards, you come back there. That's the angle 1080 minus alpha. Which quadrant is that in? Fourth quadrant. In the fourth quadrant, cos is positive. That means tan is negative. Brilliant. So I've decided the quadrant. Now 90 times 12 is 1080. 12 is an even number. If it's an even number, tan will remain as tan. So it is minus tan alpha. That's how you find ratios of angles more than 90. I just took that example just to show you how. Of course, the notes will have all these things, but the notes without an example doesn't make a difference. Sorry, it doesn't make much sense. That's why I took that example. Of course, in the handout, you'll have all these things, so you don't have to copy this. Okay? Good. Next, we are now, the purpose of the questions I'm going to do next, like simplification, identities, and so on, are number one, to understand how tricky, how to think in some cases, how enjoyable the riddles. At the same time, it gives you indirectly practice of remembering all these formulas. None of these formulas are in the formula book. I'm sorry. None of them are in the formula book, but you need to remember them because they're useful. You come across these, and if you don't remember them, sometimes in a question on integration, there's nothing you can do, or differentiation. So better, so the purpose of the questions which I'm going to show you are, apart from they themselves being enjoyable and improving your skills of reasoning and algebraic calculations and working, it also helps you consolidate these things and put them in your memory. Okay, let me see if I can get some questions on these. It's very difficult for me to make these questions. I've tried, it took me quite a bit of time. So let me see if I can do this. For example, let's say examples on trig functions, trigonometric functions of a single angle. You're wondering why single angle of theta? Because there is a different formula for theta plus alpha, there is a different formula for 2 theta, and so on and so on and so forth. Let me take, if t equal to tan theta, simplify. What have I done? Simplify t over 1 plus t squared. Very good. How would I do that? So t is tan theta over 1 plus tan square theta. So far it's easy. You don't get a mark for doing that. But look at the identity. 1 plus tan square theta can be written as sec squared theta. So can I write it as tan theta over sec square theta, which is basically, for those who can't figure out, tan theta times 1 over sec square theta. Can I say that? I don't need to, but I thought I would, so that you understand. Some of you who might not click immediately will understand. Look, sec is 1 over cos. So 1 over sec is 1 over cos, which is cos. So it becomes tan theta cos squared theta, because 1 over sec is cos, 1 over sec squared is cos squared. But what is tan? Sin theta over cos theta times cos squared theta, which becomes sin theta cos theta. You can't simplify any further. Remember, sin and cos are the most fundamental trigonometric ratios, because everything else are dependent upon sin and cos. So the fundamental ratios are sin and cos. So when you get an answer in sin and cos, so you see, even though we started with tan over 1 plus tan squared, because of that definition, and because of that definition, you are able to simplify it. So the idea is you should simplify using all those formulas. I mean, in the exam, the question would be, if t equal to tan theta, show that t over 1 plus t squared is sin theta cos theta. Or when we do double angle, the same question would be, if t equal to tan theta, show that t over 1 plus t squared is half sin 2 theta. I'll come to that later, don't worry, when we do double angles. Another couple of lessons away. Okay? I'll take another example. As I said, you don't have to copy, because these examples, similar examples, will be in the handout. For example, let's say, if z equal to, if P equal to Q sec theta, I want to know what is P squared minus Q squared. Okay? Now what am I bringing? That will be Q squared sec squared theta minus Q squared. Correct? Remove Q squared common factor. I get sec squared theta minus 1. Sec squared theta is 1 plus tan squared theta. So what is sec squared theta minus 1? Tan squared theta. So Q squared tan squared theta. No point, if you want to write as sin squared over cos squared, it doesn't make a difference. What if it is square root of P squared minus Q squared over Q? I mean, I should start from there, but since I've already done it, can I say it is Q squared tan squared theta under root divided by, by P. Divided by P. What is P? Q sec theta. What is the square root of that? Q tan theta over Q sec theta. Q and Q cancels. I get tan theta over sec theta. What is tan? That is tan theta times, you don't have to write this, I'm just writing this to show you how to work out. Tan theta times 1 over sec theta, which is sin theta over cos theta times 1 over sec theta. What is cos times sec? Sec theta is 1 over cos theta. Cross multiply, cos times sec is 1. So your answer is sin theta. Or if you don't like it, write 1 over sec as cos, cancel cos and cos, you have the answer. Alright? So therefore, that is how you simplify expressions. But sometimes, I think this is not very common. This we use when we do substitutions in integration. Especially people doing further maths, when you come across standard substitution, root of a squared minus x squared, root of x squared minus a squared, root of a squared plus x squared, without hyperbolics, we can use these substitutions. At that time when I teach you, you'll suddenly click, oh yeah, we did this in trigonometry once upon a time. And perhaps you could come back to this video and then figure out why before you proceed further. So sometimes these questions come for 3 marks. if sine theta equal to 5 over 12 and 90 less than theta less than 180, find the values or the exact values of cos theta and cot theta. Something like that. I just took some example. First and foremost, draw that. This angle is here in this quadrant. Right? If that is the quadrant, sine is positive. So, actually your angle theta is that. Remember, I could write it as 180 minus theta. So, I'll put the angle theta there. The opposite side is 5. The hypotenuse is 5 over 13 is 13. That's your positive x, that's your positive y. So do you realize this is 13 squared minus 5 squared is minus 12 because it's in the second quadrant. If you forget it, doesn't matter. It's in the second quadrant, sine is positive, so cos has to be negative. So when you find cos theta, if you forget the negative sign here, put cos theta as negative. Similarly, forget the sign here, put cot as negative. So cos theta equal to minus 12 over 13 and cot theta. Cot is, look, tan is opposite over adjacent. So cot is adjacent over opposite. Adjacent is minus 12 over opposite is 5. So that's how sometimes these questions come for 2-3 marks in the beginning of your AS paper, sometimes in an A2 paper. Alright? Good? I'm just striking various examples so that you can get used to the quadrants, the formulae and the identities. We have to come to identities. That's going to be a bit difficult. Not exactly difficult. It's going to be a bit harder than this. So let me see. Yeah. I have, I think, about 2-3 minutes. I'll show you eliminate. For example, eliminate theta from the equations x equal to 1 plus cot theta, y equal to sin theta. This we come across when you want to find the Cartesian equation from parametric equations, which will be done a bit later when we go back to the second part of coordinate geometry. At that time, you're going to struggle, so I'm showing you. At the same time, this, when you get a further math student, when you have a polar coordinates equation, polar equation, and you want to find the Cartesian equation, you might use some identities. Even though we don't, we use a different method, it might be useful. Alright? Okay. That means I don't want theta. I want a relation between x and y without a theta. So look at this. Cot theta is there. Cot is cos over sine. So if I want to link cot, I need cos and sine. I have sine, I don't have cos. So one way of doing it will be cos squared is 1 minus sine squared, and then I could do that. Instead, you see, cot squared is related to cosec squared. Cosec squared is related to sine. So therefore, I can connect cot and cosec using sine. You get the logic? So therefore, what is cot theta? Is x minus 1. What is cosec theta? Is 1 over y. So I've got cot and cosec, I can relate them. Cosec squared theta equal to 1 plus cot square theta. So 1 over y squared equal to 1 plus x minus 1 whole squared. We know how to expand this. So 1 over y squared is equal to x squared minus 2x plus 1 is plus 2. So y squared equal to 1 over x squared minus 2x plus 2. There you are. I've got an equation in x and y. Without the theta, I have eliminated theta. This is the harder one. Generally, it will be x equal to a sin theta, y equal to b cos theta. Let's take that example and finish it. So, which is a standard example, which for the math students, when you do coordinate geometry, you will come across this. X equal to a sin theta, y equal to b cos theta. Well, sin and cos are related by this. So, sin theta equal to x over a, cos theta equal to y over b, sin squared theta plus cos squared theta equal to 1. So, you get x squared over a squared plus y squared over b squared equal to 1. These incidentally are the parametric equations of an ellipse. The Cartesian equation of an ellipse is x squared over a squared plus y squared over b squared equal to 1, where b squared is a squared times 1 minus e squared. So, people doing further maths, you will have learned that in coordinate geometry. So, I have spent some time trying to show you how to use some of these formulae. In the next lesson, I'll take some identities and pick your brains about thinking, reasoning, and also algebra. Have a nice day. I'll see you in the next lesson. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.